ship. Before history was recorded, the waterways of the world carried goods and people. And for countless centuries, the needs of moving fluid cargo were adequately met by animal skins, casks, and barrels. But then, the internal combustion engine was developed, and with it came an insatiable appetite for crude oil. Barrels, jars, and skins were no longer adequate. And further technology developed the marine tanker. These vessels grew in size and sophistication to meet and anticipate our demands. At the same time, newer and larger refineries, storage facilities, and pipelines were designed and developed. However, the transfer of fluids from ship to shore and from shore to ship, that vital link was curiously ignored, with one notable exception. The exception was FMC Corporation's pioneering accomplishments in the marine handling of fluids. And ever since that initial design breakthrough, FMC has maintained an ongoing and innovative development program, which has made the name Chiksan synonymous with quality and experience. I want to show you something. This represents the vast worldwide reserves of crude oil and natural gas, loaded here into tankers, which bring the product to ports, where here it's pumped ashore for processing, broad distribution. Here are the links that Chiksan Marine Arms connect. And this is a scale model of the ingenious device that makes the connection. A flexible, yet sturdy piece of equipment, meticulously engineered to withstand high flow rates, extreme temperatures, and to operate in continuously changing attitudes to accommodate the constant movement of the ship. The operation is reliable, delivering years of heavy service. In fact, FMC's original installation at the Arco Terminal in Long Beach, California, began operation in 1956. Without interruption, it's still in service today, like hundreds of other Chiksan Marine Arms installed in the mid-50s. Today, there are over 3,000 FMC Marine Arms operating around the world, providing reliable, low-maintenance service, transferring crude oil, liquefied natural gas, liquid sulfur, and other hard-to-handle fluids. Let's take a look at some of them. At Cap d'Antifer, on the Normandy coast of France, north of Le Havre, is one of the major petroleum installations in Europe. This facility, opened in 1976, is one of the very few in the world with the capacity to handle super tankers of 500,000 tons or more. Crude oil en route from the Middle East is unloaded at this port for storage and for further distribution to refining facilities. To unload the largest tankers in the world, FMC has installed the largest marine arms in the world. They are 24 inches in diameter, with a 100-foot reach, fully powered, double counterweighted. 2 banks of 5 arms. Each arm can handle flow rates of up to 90,000 barrels an hour. Each bank of arms can be controlled from a fixed location dockside or from the vessel, using a remote control unit for better visual access. The arms are equipped with Chiksan hydraulic couplers, which are operated also from the portable control unit. These convenient, sure connections are much quicker than conventional manual bolting, and as soon as the power is switched off, a mechanical lock maintains a secure hookup. The coupler can be fitted with adapters to suit a wide range of ship's manifold sizes. A bank of these arms is designed to turn a tanker around in 12 hours, and with today's high cost of demurrage, every hour counts. And here is the heart of the FMC loading system, the swivel joint, pioneered and perfected by FMC. The design is unique. It has replaceable ball races and a split flange body. The packing units are the elastomeric type, supplied in compounds designed and formulated by FMC chemists for the specific fluids to be handled. The conventional rubber seals require no externally applied mechanical means to effect a tight seal. If in time it becomes necessary to inspect the sealing area, the split flange body permits easy access without the need to remove the ball bearings. Here is the exclusive feature of the FMC system. Note that the ball races snap in and snap out. These patented races are hardened stainless steel, and you can see how easily they can be replaced. Inserted in lighter, softer metals, these races provide greater load carrying capacity. Today, the split flange and the exclusive snap-in ball bearing races are standard features in most FMC arms. Near Teesside, on the east coast of Great Britain, Chiksan arms are helping to load petroleum products from North Sea oil. 33 arms of all sizes have been installed at Teesside. In Alaska, natural gas from the Kenai Peninsula is liquefied and pumped at cryogenic temperatures into special tankers bound for Japan. Since this first loading in 1969, and week after week throughout the 15-year project, Chiksan arms are being counted on to funnel LNG from this facility, underlining the long-term reliability of this equipment. At the other end of the funnel, at Negishi, near Tokyo Bay, the tankers offload the LNG through Chiksan arms. These stainless steel arms are fully powered and feature special cryogenic swivel joints with FMC's exclusive snap-in ball races. Here, the LNG will go into storage for subsequent delivery to industry and homes throughout Japan. Continuing around the world, we find FMC arms in exclusive use at the major receiving port of Fos-sur-Mer, near Marseille in the south of France. In San Francisco is a good example of FMC's ability to adapt Chiksan arms to custom situations. Here, coastal tankers have small, closely spaced manifolds. Nevertheless, the arms have been designed for this tight spacing, still allowing for full movement of the ship. At the world's largest port, Europort in Holland, Van Omeren operates a storage terminal that depends on FMC loading arms. These two banks of large diameter arms service ocean-going tankers for transfer of petroleum products to storage and subsequent distribution. Here, one of their 8-inch arms is manually operated by a single workman. Fully counterbalanced, it is lightweight and flexible enough to reach either side of the small dock to accommodate coastal vessels and barges destined for river ports in Europe. Another example of FMC arms adapted to small inland waterways can be found in Blue Island, Illinois. The modest throughput requirements here indicate manual operation, which can be easily performed even in adverse weather conditions. If desired, FMC arms can be outfitted with Chiksan manual couplers, reducing hookup time while providing a quick and secure connection. Further down the river, a power plant for Central Illinois Public Service receives heavy fuel oil. The arms are 8-inch by 53 foot and fully powered. Because of the viscous nature of the fluid handled, these arms and manifolds are steam traced and fully insulated, providing total thermal conductivity along the full length of the system. FMC Corporation's Chiksan arms are well suited to low temperature applications where hazardous fluids are encountered. Here, refrigerated anhydrous ammonia is transferred into storage using an 8-inch by 24-foot manually operated double counterweighted arm. This particular arm was constructed of low-carbon steel. In fact, Chiksan arms can be constructed from materials suitable for virtually any desired application. This arm is fitted with a quarter-turn butterfly valve manufactured by FMC. When the system has been purged, the valve will be closed to prevent dripping as a result of clingage of liquid to pipe interiors. For extremely low temperature service, the swivel joint used by FMC is this split flange dual main seal design. Both the primary and secondary product seals are special Teflon envelopes with internal stainless steel energizing springs for mechanical memory, as required for cryogenic temperatures. A third seal, of similar design, prevents atmospheric moisture and dirt from entering the ball races. Like most FMC marine swivels, this one can also be disassembled and inspected without removing the ball bearings from their races. Because the races for FMC marine arm swivels are snap-in type, the load-carrying components can be fabricated from material designed for greater strength. The swivel itself can be made from non-corrosive material compatible with the fluid to be handled. In this cryogenic split flange swivel joint, there's an inspection port between the two product seals. Main seal performance can be periodically monitored. The secondary, or backup seal, is an exclusive feature of FMC swivel joints for cryogenic service and provides a degree of operating flexibility unique in the industry. Near Marseille, one of the world's busiest LNG terminals is equipped with FMC arms. These 12-inch by 54-foot stainless steel arms with cryogenic swivel joints went into service in 1972. Since the early 1960s, more than 100 FMC arms, in sizes up to 20 inches in diameter, have been installed around the world for LNG loading and offloading. LNG, liquefied natural gas, is handled at minus 260 degrees Fahrenheit. Here's another example of our design versatility. At Wilhelmshaven, where LPG is loaded into tankers, a vapor return line is mounted piggyback on the FMC loading arm. Requirements at this port call for the addition of an emergency alarm and disconnect system. This emergency shutdown system has been pioneered by FMC to meet today's environmental needs and the needs of the future. This diagram describes the emergency sequence. If movement of the ship extends beyond a certain angle, the alarm klaxon sounds, and warning lights flash on the control panel. At the same time, relays trigger the hydraulic system, which stops the pump, then closes the LPG inlet valve, and both valves at the outboard end of the vapor return line. When a contact verifies that the inlet valve is completely closed, the valves also close at the outboard end of the LPG arm. Then, this valve opens, releasing pressure on the LPG between the closed valves. After a 10-second delay, this valve opens to relieve pressure on the LPG in the inboard and outboard arms. The vaporized gas flows back to the shoreside vapor return system. Finally, the powered emergency release couplings, both on the LPG line and the vapor return line, are released, allowing the arm to separate completely from the vessel. Similar fail-safe systems are also available for petroleum handling applications and can be adapted to any of our fully powered arms. New technologies in the marine handling of fluids are an important part of FMC progress. The same control panel used in this fixed station is found on our hardwire remote control unit and is also incorporated in our radio remote control system. The lightweight wireless unit is intrinsically safe and transmits on a frequency reserved for industrial applications. Remote control, an optional feature, does much to extend the flexibility of FMC fully powered arms. Another important accessory for the FMC marine arm is the Chiksan removable elbow system. The apex and riser elbows can be easily removed, and the seals handily inspected without removing the ball bearings or dismantling the arm. FMC's marine engineering expertise is available to customers around the world. Design data is reviewed with the customer, and if none of the dozens of standard designs prove suitable, Chiksan equipment will be specially tailored to meet specific installation requirements.
Nice to be here.
Some time to check over some of our evaluations on your project.
The arm we're looking at.
You were concerned about the flange loads on the ship in this area.
That's right.
We have the computer printout here, which will show you that they are somewhat high. And we can alleviate that by a support jack in this area.
Man, maybe you can explain those forces using this.
Yes, this will better illustrate our problem. As you know, the arms are balanced empty in all positions, but when they're hooked to the ship, the weight of the fluid will apply a load on the ship's flange.
Factory-trained technicians are available to assist at the time of installation. And whether it's a new installation or an existing one, these specialists are ready to train operators and maintenance personnel anywhere in the world. Satisfying our customers' needs is FMC's main objective.
I'd like to take that model back to Houston with me.
Well, it's only the same price as the full size.
Chiksan Arms, the first all-metal system for marine transfer of fluid products. Indisputably, the vital link